person involved in the present. Hello, good afternoon, everyone. From myself, Davide Dalle Carbonare, and from Sergio Gusmeroli. We are the two chairs of the Smart Manufacturing Industry Group in BDVA, and we are honored to moderate and to chair also the manufacturing track for this EBDVF. This is actually the first session of the sequence that are organized under the manufacturing track. And tomorrow we will have 3 more. We will start tomorrow morning with a sponsored session from AI Regio on didactic factories. Then we will move at 10:30 to the main session that's about AI and data technology for Industry 5.0. And then to close with the third session in the afternoon starting at 1:30. That's about digital twin in manufacturing. Welcome to all of you to this manufacturing track again. And now I hand over to Anya for the session that's starting right now.
Thank you very much, David.
Thanks to you for the time.
Thank you very much for the
welcome you all. Have a nice session.
Thank you. We will enjoy it, and hopefully also the participants. My name is Anya, and I have the pleasure to guide you through today to our very interesting session. And if you can see on our slides, on our agenda, please the next slide with our agenda, we have put together a very interesting session with different perspectives on the topic carbon reporting. And on the next slide, I will give you a very, very short introduction for this carbon reporting. After that, we will come to the different perspectives, which I mentioned just even. Our topic, carbon reporting, is one of the first and growing topics in the area of sustainability, which requires an interplay between different disciplines and different companies. That means, in detail, the processing of data, of different data from different paths for the carbon reporting, the creation of different machine profiles according to the purpose of the customer or the recipient of this carbon reporting, and last but not least, the interoperability of these machine profiles across different applications for the smart manufacturing. But how the exchange of CO2 data can work along the entire work and value chain and across different countries and different companies on a standardized basis. A team of 6 different parties, as you can see it here on the left-hand side, a team of 6 different parties with different perspectives on the topics jointly created a solution for this. And therefore, we are happy to have on board a requester for sustainability, a machine builder company, an enabler for machine communication, a data and service processor to offer an automated solution for the calculation, for the carbon calculation. And last but not least, we have a Smart Manufacturing Institute from the US on board, which presents the international interoperability of the data and machine profiles. I'm really pleased to present today now the different components and the different parts of this entire solution. Let's start. On the next slide, we will start with the first and basic question. How can digitalized and network manufacturing benefit sustainability? Peter Post will explain this to us from the perspective of the platform Industry 4.0. Peter, please, let's start. The stage is yours.
Yes, thank you very much, Anja, for this kind introduction. I would like to go directly into the slide. Please switch to the next slide. Platform Industry 4.0 is a networking cooperation platform where we have all stakeholders coming from different activity fields, from business associations, from science, from economy, policymakers, trade unions, and so on, to move this big thing what we are going to discuss within the digital transformation of industry together with all the different aspects we have. And the platform is the central hub of a digital ecosystem for digitalization of industry, which we have implemented in Germany. Next slide, please. Here you see our vision 2030 for Industry 4.0, which mainly consists on three columns. First of all is autonomy. That means trusted data exchange, more or less is this the most important thing. Then interoperability, so that if people are going to exchange the data, that will work on a good sounding architecture. And one big field, a good field of application is the sustainability field, and we are discussing how today the aspect of sustainability, especially in this context of climate change, mitigation, and the circular economy. Next slide, please. Within the platform, we have, and the next three points, one, and the next one, and the next one, thank you. We have developed here three different paths, which are shown here in this slide, and I will go a little bit more in detail into these three paths. So the first one is to just reduce consumption and to increase the impact and to reduce the CO2 footprint and to be responsible with resources. That's the one side. The path three on the right-hand side here is how do we have to change our methods how to work together, especially when we are thinking in the context of circular economy, and what are the basic assumptions when we are working together in sharing our main aspects of sustainability. And in the myth is that there are a lot of chances to pass through. Two is there are a lot of chances to develop new business and new business fields and activities within service offerings. And I will go through these three paths with different examples before we go to in more details in the following presentations. Next slide, please. The first path is reduce consumption and decrease impact. That is what everybody can do on its own shop floor level. That means to make an efficient use of energy and an efficient use of resources. More than 40% of global electricity consumption and nearly 80% of global coal consumption can be attributed to industry. And here we have to do a lot of work. Great savings potential can be discovered here and can be improved, especially in the context of energy consumption. Let's go to an example, next slide, which shows that we have to go into detail to solve this big problem, because efficiency is one of the activity fields in the last decades as well. Here we have an energy monitoring at a component level, the E²M energy efficiency unit, where you just measure the energy consumption, the usage of pressured air in a specific plant, in a specific application. And this is the basic consumption, so that you finally can implement control mechanisms, and third, that you can do this management of consumer. And to do the management of consumption is not a thing where you have one specific unit which you can apply. You have to think in a total system approach. Then you are going to the next slide, please. In the next slide, please, here you see the Festo energy transparency system, which we have already implemented in one of our factories. There are a lot of such intelligent components which needs to be combined in a consistent architecture with data exchange from one component to the others, coming from different different implementations, so that you can get the general holistic view of how to manage the energy resources of overall on the overall factory. And this is done to exchange data on a high quality level, for example, to give the access to control data from standard UPC UA clients. Just to give you an example that within this path, reduce consumption, increase impact, you have to go into the details, in the vertical details of your production lines, and to combine them together on a good data exchange basis. Next slide, please. The second path is from mass production transparent services offering. We have to think about consistent methods of lifecycle management. We have to come from an overall lifecycle management which replaces the sales based on the sell and forget principle. The responsibility of a product is a responsibility we have through the whole lifetime of a product, and we have to accompany the product through the different aspects of application. We have to implement sustainable twins, material paths, remanufacturing things, and reverse logistics. And there are a lot of activity fields we have to discuss, and to think about how can digital solution help us in these contexts. Next slide, please. Here are two examples from the LuxR company and Kaeser compressors. Let's start with Kaeser compressors. The company Kaeser, for example, they are providing air compressors for compressed air for pneumatic applications. And they are going into a new business model with we do not supply you with compressors, but you can buy compressed air, cubic meter of compressed air from us, and we implementing the compressors at your site, and we are going to see that they are working really efficient on a high efficiency level. Or the LuxR company is a startup nearby here in our area, and they are offering services how to manage overall pneumatic networks in practical applications in the real use of plants. The main aspect is all these new business models are based on sharing and analyzing data and to efficient combine data together on a trusted level. Next slide, please. Sharing and networking, that is, I think, a big task we have to discuss throughout industry within the next future. What are really the basic consumptions that circular value-added networks can work together? How can we change from the proprietary production plant to shared value-added factor, and to combine different aspects in these things so that value-added networks on a totally different concept are going to support all these aspects of circular economy. Next slide, please. For example, we have a research project within Germany, which is named Catena X, where we have a data-driven value chain from intra to intercompany, and which has a sustainability as network task. And there are many, many partners working together and thinking how a good solution should work when we are going into these new sharing and networking world. Next slide, please. basic of all this is the aspect of all things of interoperability. That means we need digital twins, standardized internet representation of all of our intelligent components. One of the most important thing is this asset administration share we have worked a lot of, and I'm just giving here the presentation to Mr. Hofmeister, who is going to discuss it a little bit more in detail in his next presentation. So I'm finally already on my end with these three paths of sustainability, and hope that I could give you these impressions that the basic thing is that we are going to exchange data on a high value, and that we have a trustworthy concept of data exchange, which is the basic of the future productions which in this context. Thank you.
Thank you very much, Peter. I think that was a very short but very exactly introduction into the topic of sustainability and carbon reporting. I have to ask, are there any questions in the chat for that first presentation to Peter? Seems not to be the case. Okay, if you have other questions, then please write it down in the chat and we can answer it afterwards. Thank you very much, Peter. And that brings us to the next point. What does this topic and the upcoming requests regarding carbon reporting and sustainability mean for machine builders? How can an implementation in a machine builder company look like? And the other way around, and how could contribute a mechanical engineering company to Industry 4.0 and sustainability and carbon reporting? Michael Hofmeister and Stefan Kapp, just even mentioned by Peter, from Festo, took a close look at this topic and developed a solution based on the data from a learning machine from Festo. And in our next session, Michael Hofmeister will show you the way they went. Michael, we are very curious about that way, and with that, the stage is yours.
Thank you, Anja, and good afternoon also from my side for our combined session here. As Anja was already pointing out, we serve here as a viewpoint for a mechanical engineering, you could also say machine builder, for our common Industry 4.0 and smart manufacturing vision. What is Festo? Festo is a company deeply involved in assembly, in factory processes, but also in process industry. And mostly our portfolio is consisting of industrial components. You see here on the left-hand side, our range of industrial components, a lot of things which are done out of aluminum. Electronics is for sure involved, but also controls. And we are doing quite a turnover with this, roughly 3.3 billion euro. What is really also remarkable is we have over 300,000 customers in more or less all factory sectors. You will find products from us. We have a considerable amount of staff, and you find us all around the world. What is really important also to know is we have really a lot of different products. Currently, we are delivering over 33,000 types of products to the market. This also requires that we are doing a lot of innovation and R&D, and so we have here also quite considerable share. At the same time, we are also serving as a provider of technical education, and this is what you see on the right-hand side. And in order to do so, we are also providing the market with little systems, which can also do production in a certain sense. These are our learning factories, and from these we can gain a lot of insights also how machine builder business works and what are the requirements of our customers. And looking at this, I would say that information and knowledge transfer is really crucial also for our business. This upcoming Industry 4.0 topics are really important. So let's go to the next slide. And here a little bit complicated, but I wanted to give you the full picture. What are the challenges if you look at the life cycle of a factory, for instance, which is doing some consumer good, like, for instance, a smartphone. So at the very beginning, you will have a product definition phase where you already start to describe by digital tools what we call the digital master. With simulations, for instance, you establish a view if the product is working correctly, you want to do test ups, you want to do mock-ups, and so on. And after this first phase, you're going to decide to do this into production, and therefore you need a factory, a production line to do so. And this is what we call the digital manufacturing twins. So you have to use a lot of different disciplines here: CAD, construction, electrical diagrams, but also robotic programming, layout planning, logistics simulations, material flow, certificates, and so on, until you are up to a point that you really can automatically produce products. And then you are not at the end. On the right-hand side, you want to run this production, you want to be operating, you want to produce products, and you want to put them into the market. And this means that you're also getting data back, for instance, quality data from the running production, but also usage data out of the field, maybe also incident reports or things like this, which is reflecting rework. And here you have to cover a lot of different use cases, like predictive maintenance. You surely have heard about this, process analysis tools, artificial intelligence, or augmented reality, you name it. We have now two challenges. Data and information models are expensive. This means all these things only pay off if you are able to integrate data over the life cycle and are able to reuse this expensive data multiple times. And therefore, we need an instrument to really do a data integration along the whole life cycle, even if it's spanning a lot of different departments in our company, or even if it's really also being across some supply chain network. And the second challenge is you will get a lot of different components and systems from the market you have to integrate into your factory. And this means you have to integrate a lot of different digital twins. And this is what Peter was also explaining. You need interoperability of this digital model, because only if you can combine them like Lego brickstones, then you are efficient enough to build all these digital manufacturing twins that they are really paying off in your life cycle. Let's go to the next slide. And this is also what we as a supplier have to care for, that we provide all these different digital models. And I named here some of these digital models, for instance, digital nameplate, serial number, things like this. Handover documentation is a big task for us, but also know-how and trainings for our products. We provide you with specific technical data, which is really specific for the very product. And then also all kind of construction details for the CAD or for the electrical planning. These are all kind of specific information which are updated over the life cycle, not every day, but we need to update them from time to time. But then we have also information like process data, which is really coming up near real time, condition monitoring, refined capabilities of the equipment that you can talk to these capabilities in order to do something like process parallelism and things like these. These are all things we need to integrate also on the runtime. And this means the digital twin is consisting basically of two things which need to go together. On the right, left-hand side, more static information, and on the right-hand side, more dynamic information. And what is really important, we are looking here from the terms of view of sustainability. In the future, we have to do a product carbon footprint from nearly every product we are producing, describing the scope 1, 2, and 3 shares inside it. And in order to calculate these kind of footprints, you need also the carbon emission reporting, which is currently happening in the factory. And therefore, this is an activity we want to reflect in our demonstrator. The bad part of the news is that we have to do all these digital duties for up to 33,000 products. So please keep this in mind. Let's go to the next slide. And these were then also our demonstrator goals. We wanted to create a demonstrator which is showing a lot of different competencies you have to cover in the technical education, but also then in the operation. It should generate a wealth of different experiences in terms of what kind of industrial processes are being here involved. It should be simple to maintain and also reconfigurable, that we can really create a lot of different scenarios. Our two main cases are CO2 monitoring and carbon footprint, but also to show the digitalized life cycle of factories a little bit with our different kind of modules. And on the next slide, you see these modules. These are the modules our demonstrator is consisting of. And you see that a lot of different electric and fluidic control processes are incorporated. We have a lot of typical automation gear installed into this, together with different PLCs, which do, for instance, in the data monitoring. And we want to end up also with mobile tools, and therefore IoT as a kind of coupling point between these kind of factory details and then what the consumer, but also our staff is using. Yeah, this needs kind of gateway functionalities and Internet of Things. And this brings me to my kind of requirement analysis, that here 3 distinct technical domains are being covered. On the left-hand side, you see this is what Festo is mainly concerning about, the machine level. Here you have industrial PLCs, which are then also providing a lot of data points at the runtime. You see here the blue connection to our gateway. And what is coming more and more into play is interoperability, for instance, by the means of OPCOA. But then our customers have to do a lot of duties, and we want to serve our customers in easing up these duties by having to serve for a lot of aggregation levels. You need to have high availability. You don't want to happen that your complete factory is standing still because your data center is down. You need to persist large data assets. If you think, for instance, on construction details or simulations or things like this, you have, but also to persist large data sets. For instance, get all the important quality data from all your machines over multiple years. This is really producing gigabytes and gigabytes of data every day. And then also this aggregation level needs to take into consideration external data, for instance, energy pricing, all these CO, carbon dioxide emission factors, which are depending also on the overall situation of the world, hence the small diagram here. And even you have also to consider that policies are changing over time, that business logic is changing over time, and you need to be able to reflect this as soon as possible. And basically, you have to see that the customer wants the application level. He wants an efficient planning or engineering. She wants also to do a quick and profound simulation, a virtual commissioning of things. We want in the shop floor to have a quick operation, quick maintenance task and reconfiguration. And then we have to think also of these processes like regulative duties, such as reporting on CO2 emissions and product carbon footprint. And basically, for all these kind of applications, we need to go back to the aggregation level to get our data. And this is what we are really trying to face also in our initiative here, and also in our platform Industry 4.0 and the smart manufacturing Sesame is concerning about. Next slide, please. And from the point of view of Platform Industry 4.0, we created this principle of the asset administration shell. So we are taking more or less all these different data models, we call them submodel, under a standardized package, which is called AAS, Asset Administration Shell. And the new point is that we are now making this kind of technology available for a lot of different asset types, like components, like machines, like produced products, like raw materials, like processes, and so on. And therefore, we want to have a kind of standardized infrastructure within our value chains, but also within our factories, which is always able to handle a lot of these different digital information models and pass them along the whole life cycle, but also treat them as a good reference point for the production process. And this requires a lot of different interoperability levels, technical like protocols and things like this, syntactic, semantics, but also organizational interoperability, that this is going along the life cycle. And this means that we really have to have strong partners to took this into reality. Platform Industry 4.0 is such a partner. We currently created also a user organization for the asset administration shell. This is the IDTA, the Industrial Digital Twin Association, and we are doing also a lot of standardization within the realms of the IEC standardization organization. Next slide, please. And here you see fresh from standardization, more or less the overall picture of what we are doing. In the middle, you see as a kind of blue core, our administration shell, which is a technical, logical, neutral UML model. And then we can pass information into automation ML, which is important for engineering, into XML and JSON formats, which is more or less a coupling to the customer's business processes and so on. And then OPCOA, for instance, which is really the technology to go if we are talking about the operating phase, what is happening on the shop floor. And we want to consider a lot of different subjects here. We call them submodel on the lower hand. And the idea is to have then always the same interface to provide a lot of different services and applications with this information, that we can really take advantage of these information models. And these applications are in the fields of planning, engineering, reporting, prediction, simulation, and maintenance. And this means that basically you should be always inside a factory or a supply chain able to ask as administration shells for all these different data by the means of our frameworks. We will use a lot of different technologies. You see them on the left-hand side. And what is also really important to be mentioned are some boundary conditions, like, for instance, creating data quality, but also information security. Information security is really key. Without information, we will not be able to share this information in data federations and data spaces. And therefore, it is really key that we establish a high amount of information security. I will come to the questions a little bit later, if you allow. Next slide, please. And this brings us to the last point. Here, you see the asset administration shell of our demonstrator, and hopefully the video is also working. If we click again, you see here that we are loading one certain asset administration shell. We have then these different submodels, which are, for instance, concerning about nameplate information, but also documentation. I can go directly to the documentation of each and every asset. I don't have to search for it. I don't have to interpret. I can use this documentation basically from every CAD program or engineering program. I get specific computer readable data sheets and information with a lot of different languages and so on. And now we are going to the carbon monitoring aspect of our demonstrator, where you see that we are gathering all these different important energy information, like phase voltages, like phase currents, but also then the pneumatic energy is being really recorded for the different stations inside the demonstrator. And if we click again, please, there's a second part of the video on the next slide, I think. Please go to the next slide. Please go to the next slide, please. Please go to, yeah, here we are now correct. Yeah, and now we see that these numbers also running. Yeah, so you are not only able to access static information, but really also dynamic information. And here on the kind of charts, you can really see that different products are running inside our small production line, which you can also influence. And you see that the different energy fractions are now changing over time. And basically, you now have to analyze this inside the aggregation level for the different purposes I've described. And I think this is now bringing me to the end of my presentation. Thank you a lot. Yes, and there has been a question from Frank. Frank, you ask if there are APIs. This is an important part of the mission we are doing. We are providing for the asset administration shell basically standardized APIs that you can access all this different information. And we are packing these APIs into frameworks we call repositories that you can manage a lot of these different asset administration shells all together and allow also interactions between them. And then you can imagine that also energy pricing, CO2 prices, something like this are wrapped also into these information sources and are then taken into account accordingly and really to the runtime. So I would expect that energy prices will change over the day and that they maybe also influence the production over the day according to these prices, but also to your load requirements, which comes from the scheduling systems, for instance.
Thank you very much, Michael. That was really, really amazing and very interesting to get this overview from you and also a deep dive into the data and into the processing of data, and to get really the solution how a machine builder can handle this topic, carbon reporting, in the course of sustainability and in the course of this or in the usage and with the usage of solutions from the Industry 4.0 area. Thank you very much. Really amazing.
You're welcome. Yeah, and I'm looking forward to questions even afterwards. I think there's a possibility.
Yeah. Great. That would be my next question. If are there any questions, then please write it down in the chat, and we would be happy to answer that afterwards. That brings us to our next section of our session here. An essential step in the exchange and forwarding of the data is the communication between the machines and the assets. That brings us also directly to the question, how can a semantic, secure industrial interoperability could be enabled? OPC-UA is a well-known and tried and tested solution. We have heard all about that solution, and therefore Stefan Hoppe will show us just now a very short intro in OPC-UA, but also above all the diverse applications for the machine asset communication. Stefan, we are very interested in, and the stage is yours.
Thank you very much, Anja. Yeah, as mentioned, it's a pleasure for me to be on stage here. Let's start immediately with the details. I give you just a very short update on the next slide about the OPC Foundation. We'll not go into all the details, but from my point of view, we are very proud to have more than 850 members around the world. And the mission is exactly how to establish semantic secured interoperability, scaling completely independent from any vendor, agnostic to markets, and scaling from field to cloud. And openness is exactly our keyword. Everything what we do, specification, sample code, but also certification is open, and you don't have to be a paying member of the foundation. Next slide, Adrian. We are really proud that all of our members are not only in the OT world. You see really that it's a good mix of everybody, including IT companies. And that's why we sometimes are very proud saying we feel a little bit like the United Nations of automation in the best meaning, saying that it's democratic and that every company only has one voice independent from the size. Next slide, Anja. Looking really to the technology, you have to understand, and that's my main message here, OPC-UA is not a protocol. There's not one single protocol in the world which is able to fulfill all requirements. You have different requirements if you talk in cloud or field level. So OPC-UA is more, how can we move standardized information in a secure, end-to-end secure way? And this is exactly where OPC is scaling horizontally, but also vertical from the field level up into cloud. And so we are moving standardized data over different other protocols. And this is an ongoing solution. OPC-UA maybe never be finalized, but it's always workable and it's always able to provide you solutions. As I mentioned, standardized information, this is where we work together with other key organizations like Sesame here on this call for because we are using their expertise to standardize information. Next slide. Overall, and this is with all serious organizations, we have the interoperability itself. We work with all the partners, which is here listed in different areas, in discrete process, but also energy. And we also provide, for sure, validation and certification. I like to mention one partner who has selected OPCUA. That's the next slide, Anja, where we are proud why they selected. Please click through all the details. Why they have selected OPCUA, and this is exactly because OPCUA is open, because it has integrated security, it is movable, it transfers data via different protocols, it is a semantic description, and it scales from sensor to cloud, what we see later on. Next slide, please. Also internationally, we are recognized as the most important interoperability technology as an enabler. For example, here what we have seen here for the asset administration shell in the life cycle of the operational data. This is where mostly OPCUA is seen and set as a standard worldwide, and this has been confirmed by analysts on the market. Next slide. Again, I want to highlight for 2 slides only that it is one solution, which is for different industries, factory and process, but also scaling from sensor to cloud. On all this is one harmonized solution with OPCUA. This is exactly what the market is asking for. Next slide. Because sometimes people believe, oh, I need different protocols, and hey, MQTT is so cool and that's popular for the clouds. But honestly, this is not enough. I'm not going into all the details because MQTT is a fantastic, great protocol for connectivity, but it doesn't mean really the definition of the payload itself. And this is where the combination of OPCUA with the standardized data on top of OPCUA is exactly what the world is looking for. And we are very proud to have commitment from all the big cloud vendors, what you see here on this slide. All of them are either delivering already OPCUA, PubSub over MQTT, or it's on the technical roadmap. Next slide. So as just one example, I like to highlight here at the end of the presentation that OPCUA is not academic, it's reality. It has been adopted by multiple huge international enterprise companies. One example here is Equinor. And they have chosen OPCUA because exactly they wanted not only to transfer data, they wanted to set data into a context, that it becomes a meaning, and that the data has a relationship with each other, and which is great, a great enabler to do more analytics on top of the data and have them available everywhere. So if you want to get more information, feel free and look for that in the web. Anja, that was my presentation. Thank you very much.
Thank you very much from my side. Question to the tech team. Are there any questions to Stefan in the chat? Yes, there is one. No, there is not. No, that was another hint. Okay, then thank you very much, Stefan. And with that, we come to our next point. We have just now learned how a machine provider can generate and process data for carbon reporting, for instance, and how the data can be communicated and processed furthermore via OPCUA. You have seen it just even. The question now is, how are the data processed and prepared for the recipient or for the customer so that he or she can use it according to her or his purposes? There must be one point at which all the parts and sections are brought together, at which the data are integrated and transformed into the different various machine protocols for the further use by the recipient or customer. Erich, we are very curious to see this solution, or which solution you have developed from Microsoft to connect all these dots together. Erich, the stage is yours. Thank you.
Thank you, Anja. So next slide, please. So fundamentally, we obviously worked in partnership with the platform Sesame, the Labs Network, Festo, and the OPC Foundation to build a solution. This wasn't just Microsoft. Microsoft is the platform provider for making such solutions possible. The solutions themselves are obviously built by our partners. For this demonstrator, we have connected a Festo machine using the Festo gateway that Michael Hofmeister showed earlier on, and connected this gateway to a cloud gateway, which you see in the middle of the picture here. And the communication mechanism that is the standard these days for this kind of communication is OPC-UA pops up, which is what Stefan just mentioned, which uses a JSON payload with MQTT as the protocol, and then that data is transferred into a time series database. So a time series database is very useful when you're collecting manufacturing information from your production lines, because they're time-stamped and you can easily run analytics on this time series data. It's obviously important that the time series data is in a standard format that A, doesn't lock you into a proprietary solution, and B, makes you compatible with other data coming from other sources. For example, your MES system, or a third-party system that you're also using on the shop floor. In addition to that, the asset that is being built, so the asset here is the machine, but the asset that ends up in the asset administration shell is the asset that is getting built. For example, let's say it's a bottle top, and if you're building that bottle top, you may have an information model that describes its use, and you can put that information model into a separate information model database, and you can make that information model also available to your customers via the asset administration shell. The OPC Foundation has recently launched an online store of information models called the UA Cloud Library. And the cloud library can be used for such information models based on OPC-UA. So obviously the asset administration shell has also data from other sources in them. Michael Hofmeister already alluded to that. So in general, the asset administration shell will tap into several databases, including a time series database and information model databases. So the asset administration shell obviously needs to be made available to the customers of the manufacturer producing these assets, these smart bottle tops in my example, and they may need to actually report the carbon footprint of this smart asset, or they just want to because it's something that differentiates them from the competition. So in general, we see more and more that carbon footprint data is being used to differentiate a product, or in fact because it's required by a customer. So then the customer can use a standardized interface to access this data using an asset admin shell client, and then use that data in their own systems, for example, in their own ERP system. So in general, what that means in terms of carbon reporting is that the carbon getting produced during the production of the smart asset, which is usually referred to as primary emissions or scope 1 emissions, become secondary or scope 3 emissions by the customer. And then basically when you're building a smart product, all the different emissions from all the different stages along the supply chain need to be added up to make up the final carbon footprint of the product. Next slide, please. So what does that look like specifically? So obviously most of the systems getting used in such a environment have their own dashboard. So here is a view of the time series dashboard that, for example, the Microsoft time series database called Azure Data Explorer makes available. And you can build these dashboards relatively easily by clicking on the right data and picking the right data visibility tools. So, for example, line graphs, and then obviously you can use that in your own production environment to do condition monitoring or OEE improvements, et cetera, et cetera. Next slide, please. So here's a screenshot of the OPC Foundation's cloud library. Like I mentioned, this was just released last week, and it can be used to store these information models that can be used later on in the supply chain for production purposes. Next slide, please. And here is a view of the actual asset administration shell server. It can also have its own user interface that people can use to browse the information. In this case, we have a very similar view like the asset administration shell client has, and all the information that is provided and collected from the different databases that Michael Hofmeister talked about is provided here in an online dashboard format. Next slide, please. And here finally we have the asset admin shell client that Michael Hofmeister also showed in his video. And as he mentioned, the same information that is in the asset admin shell can be displayed there, obviously, and then extracted from the client to be used further down in the supply chain, including carbon footprint information. And next slide, please. Now you're just showing the video again, so just go to the next slide, please. Correct, and that actually brings me to my next speaker, Jonathan Wise from Sesame, because Sesame have actually plugged into this particular platform as well and have extended it with the smart manufacturing platform that Sesame is using. And it's again compatible because it's using the same standardized interfaces and standards. So I'm at the end of my presentation.
Thank you very much, Erich. And that was a brilliant bridge to Jonathan. And I only want to add one additional information. Sesame, we are really very happy to have Sesame as a smart manufacturing institute from US here on board, because if you are talking about international interoperability, that means not only related to Europe, it's also related to intercontinental interoperability. And therefore, we are very, very happy to see Jonathan's presentation, how the Sesame colleagues handle that topic we have presented just now for Europe, also in US. Erich, thank you very much. And so, Jonathan, now the stage is yours.
Well, thank you, Anya. Thank you, Eric. I'm pleased to be here. Sesame is one of the the Manufacturing USA Institutes. Our focus is smart manufacturing and clean energy. We apportion federal funds to invest in projects that accelerate these two ideas, smart manufacturing and clean energy. And we're very, very pleased to be working globally with other organizations that have the same goals. I want to pick up from the architecture that Eric was talking through. And if you can go to the next slide, show where we connect to this. No, back one slide, please. Back one slide, please. Wrong direction. Thank you. Show where we connect to this flow of data. So we have this kind of stream down the middle where the data is flowing from the source, finally to the asset administration shell client. And what's making this work is that there's a common information model used all the way throughout. Sesame is able to leverage that same common information model to add a new value stream to this data stream. So we don't interrupt or we don't overlap with, we augment by exploring new things that we can do with the same data. So now if you'll go to the next slide. Thanks. One of our main initiatives is to advocate for common information models. We've been calling these things smart manufacturing profiles, but they are conceptually and structurally similar to an asset administration shell, particularly a submodel template within an asset administration shell. And I saw a question come in over the chat. What's the relationship between OPC UA and an asset administration shell? A profile is also called an information model, and we can express an information model as an OPC UA node set in a standard language. So that language is what Sesame uses to define profiles. And a key missing piece that Eric alluded to is we need a place to go find these profiles or find these templates. So that cloud library that Eric talked about is something we're very proud to have worked on for the past year and a half. It is a central repository or location where you can go find templates or profiles or common information models that have been published by experts that you can download and use in your own system. Our view on these profiles is they're not just a way to describe the data, but they actually become an interface for software developers. If you want to develop an application, you can build it independent of a particular machine or a particular piece of equipment by building it against this profile. So if you could click ahead on the slide. Thanks. One more time, please. So this is what we call the Smart Manufacturing Innovation Platform. And the relationship with this diagram and the previous diagram, the cloud library is that information model repository. And the data source for us is this stream of data that Eric's created going from the asset. The Smart Manufacturing Platform, if you go to the next slide, is what allows us to expose, back one slide, please. To expose this structured information to an application developer in a way that they can expect. It effectively becomes a contract for application development. As an app developer, I can expect this data to be fulfilled by an underlying platform that implements this profile or this common information model. Sesame works on a membership model. So we have members from organizations all over the US that are participating. One of them is a company called ThinkIQ that has built out an implementation of this platform idea that allows us to rapidly assemble application value on top of the data value based on this contract or based on this promise that expected data structure will be fulfilled by the underlying data stream. That allows us to abstract the problem of application development or machine learning training from the problem of getting access to the data. Eric's shown how we simplified getting access to the data and kept that common information model, that data contract, consistent all the way through. And what I'd like to show in a brief demonstration is how we've tapped into that common information on that data stream to create new information value. So we're going to connect to the Festo machine as our data source on that pipeline that Eric showed. And we're going to look at the individual parts of the machine and provide the appropriate conversion for the different components to understand our CO2 output. We're going to aggregate those CO2 levels up to the asset level, but then also imagine what it's like to look at a plant and enterprise level so that we can set limits and targets within our enterprise for the CO2 performance that we want to hit. We also want to be able to drill into equipment. So once we spot a problem area, be able to dive down and figure out where we're not hitting our goals. So if I could start screen sharing, we'll show this brief demonstration.
Jonathan, we cannot hear you. Can you please switch on also the...
So we start here with the common information model. You can see that the information model for the Festo MPS 403-1 is a part of a library of lots of different information models. What's important about this one is that we've agreed to interoperate on this information interface. The type definition is made up of subtypes. We might call those submodel templates. At Sesame, we call them profiles. And profiles can be made up of other profiles. Exactly what words you use to describe these doesn't matter. What matters is that we have a common information model so that as an application developer, I know what to expect when I connect to a data source. So this is the type definition in the abstract. I can also see a specific instance of the equipment actually connected to a data source. So here is the MPS 403-1 sitting in Germany that I'm connected to. And if I want to, I can trend the data live from that machine as it's coming in across the internet through the Azure Data Center. What we wanted to do for this demonstration is take this MPS 403-1, which is a training unit made up of multiple stages and phases, and imagine what it might look like if we standardize on this information model across a plant and across an enterprise. So we've extracted the different stages and phases that are a part of this training module, and we've attached them to virtual assets in this demonstrator. One of those assets is a batch tank, and you can see that the batch tank is made up of submodel templates or profile implementations that have some of the data that we're getting from our training asset. The mixer motor is a component of the batch tank. The mixer motor itself has a profile that allows us to understand the data coming from the mixer motor. The batch tank has a profile that is the carbon module. The carbon module helps us to understand the carbon output of the batch tank. But the motor itself also implements the carbon module. So if I look at its attributes, I can see that CO2 emissions are a useful data point. And I can also see that the motor can't tell me its CO2 emissions by itself. It can tell me its energy use, but I have to combine that with the energy source to really understand what my carbon footprint might look like for that motor. Then when I drill into the motor, I can see meaningful carbon data as part of the carbon interface for this part of a larger asset, as well as seeing the carbon output of the larger asset. And I can trend this as well if I'd like and get as much detail on the component data as I want. The component being part of a larger asset. The asset is part of a larger system. So the motor is part of the batch tank. The batch tank is part of this plant that I have in California. And each asset in the plant has standardized on a common information model for CO2 reporting. That allows me to look across my facility and get a rolled up KPI of the CO2 equivalent output, and even identify where my problem assets are and the components of that asset that I might want to drill into. This is the sweetener batch tank. This is its relationship with the other assets. And this is my indicator that I'm out of the target range for CO2 output for this asset. I can trend that data as well and dig in deeper. I might also produce reports. As well as looking at live data, I may want to standardize on reporting across my sites. So I can use this same tool to produce those reports that allow me to compare across assets, or more importantly, across sites. So if we zoom out one more level, I can see that the California plant is part of an enterprise that has plants in different locations around the world, all of which have standardized on this common information model for CO2 reporting. And that allows me to compare my California plant's output with my German plant or my UK plant. And from there, drill into the details on those facilities as well. The common information model allows me to interchange data between sites, but also understand information as compared between sites, to interoperate on a common set of KPIs that can help me do better, not just at the component level or the asset level or the site level, but across my enterprise. So we start here with the common information model. If we could go back to slides, that would be great. Thank you. And one more slide forward. So what we tried to show with this demonstration is how easy it is to share data between the software components. So in that whole architecture, we're passing along the same data, but it works between those components because they have a common information model. What we showed is that we can easily develop applications of that data. So there are a variety of different applications that we're using the same information model layered on different assets or different sites and for different purposes. But all of them independent of the original data source. So I don't actually have a connection to the original data source, but I have a connection to common data in a common reliable structure that can allow me to build these applications. These aren't just visual applications that I can build in this fashion. This is a reliable set of features that I can use for machine learning training and redeploy a trained algorithm anywhere those features are present, anywhere the profile has been implemented. This standard information model also allows me to standardize reporting and KPIs. So I can compare across assets or across sites and set targets to work towards improvement. If we could go to the next slide. This is the end for me, but we only had a brief few minutes. So if you'd like to learn more about Sesame, please visit us at sesame.org or email us at info@sesame. Our development initiatives are all largely open, and we would love to engage with you on the web via our GitHub as well. So Anya, back to you.
Jonathan, thank you very much. I think that was amazing and very impressive how Sesame as a machine building institute in US is proceeding the data. The same data they got from a German Festo machine and using or based on the same logic of our calculation and using same information models, and evaluating and creating the data for the US shop floor market. And that is really a very, very interesting interlink, and presents also that the data we are just now handling not only related to Europe, they are related to intercontinental interoperability of machines across the world. Thank you very much. As you can see here, before we come to our outlook and conclusion, I have seen there is a question in the chat from Liliana. And I would like to ask Michael and Stefan to warm up for that question. Liliana asked, the OPC UA Foundation has developed many OPC companion specifications. Platform 4.0 and IDTA, that is the Industrial Twin Association, are currently developing standardized submodels. It is planned to combine them, for instance, to generate an asset administration submodel template based on a specific OPC UA companion specification. For instance, OPC UA for CNC machines or OPC UA machines for UMATI and robotics. Is there plans to have that combination? Michael and Stefan, who want to answer first?
Yeah, I can start maybe first. And first of all, I like to give a short answer in the name of our friends from VDMA, because UMATI is not a companion specification. Let me phrase that. It was a little bit, they changed the meaning of the T. It is no longer tools, it's now called technology, and it's a user association. So, but back to the real question, and that's exactly about the companion specifications, and I take it in a more broader scope. In my presentation, I mentioned that the OPC Foundation right now is doing 66 companion specifications. A lot of them are released. Part of them we are working with our partners. And first of all, we have to understand, and Michael will explain it in much more detail, that the information models status today defined by the OPC Foundation and partners is really dedicated for the asset level. What is a robot? What are the what are the properties, the functionality of a robot, of the CNC machine mentioned here, and so on. And this is a very technical description, how to interact with the device, how to get status data, or how to tell the device what to do, how to tell the asset what to do. In the upper layer, in the asset administration shell, we collect much more information across the life cycle of products, including many more business related, or here carbon, CO2 information, which come from other places. And this is why having an asset administration shell collecting more information, even offline information, documentation, makes absolutely sense. So the companion spec is not equal to from my point of view, to a submodel, but you are leveraging data from information models, which has been defined by the experts of specific domains. And so this is why we obviously respect their job, because they are the experts. We don't want to make another copy of a domain specific information model just to do it again, right? And it was not defined by others. So we need the good combination, and that's why the OPC Foundation is in a really good relationship here with EDTA and working exactly on that to explain it in a better word. So this is a really great question. Michael, I think you can explain it in better words from the other point of view.
Yes, thanks, Stefan. I think the big message is also what you pointed out. Yeah, we don't want to reinvent the wheel, and the VDMA did a lot of activities, for instance, yeah, to describe machines in form of information model, and we're gonna respect this. And then you pointed also out that the asset administration shell gives a lot of more information to lifecycle aspects, yeah, and via our mapping we have described in the I4IAS activity, a joint working group with the OPC Foundation, we are able to take basically every AES submodel, yeah, and make it also available as OPCOA information model, yeah. So we are really leveraging here the information which is available on the point of time of production. And we have some other discussions also to be able to describe any kind of information model from OPCOA via a kind of nameplate. These discussions are ongoing, therefore I don't want to say something here. And the last point Liliana was, I think, pointing out is that some information which is in companion specs, yeah, should be also available back on the AAS level, yeah. And here I think we will also take the mapping way to reroute this information, but for sure nothing will become obsolete, I think, yeah. And therefore I think we should answer this question in a way that we say we are very good aligned in what we want to achieve. Yeah, we want to have information models. We don't want to reinvent them, and we are currently also clarifying a little bit the technical details.
Mm-hmm. Okay, thank you very much, Stefan and Michael. And there is another question from Liliana. I think that goes in the direction of Michael. Let's see. How do you combine historical data and the asset administration shell? There is a submodel template for storing historical data, but the AAS API does not support querying this data. What I understand, Michael, you could have an update for that question. Is it possible to answer this question today here, or do you want to have that offset?
I think we can do a larger conversation afterwards, Liliana. I think to a certain degree you're right. Yeah, what you have seen right now is our first achievement of this time series data specification, and this time series data is not just handling some kind of data which you just recorded, but you can also describe, for instance, then the requirements for a axis motion or things like this. So this specification is rather universal. And the data is then being expressed as part of these submodels, and therefore with the REST interface we just recently published, you can, for instance, also query for this submodel data, and for sure you can also query them for parts of these time series. We have also now a kind of update mechanism that you really can listen to changes of the submodels via different technologies, and then you can see how a submodel evolves over time. What is kind of missing here in your question is that we have an active querying interface where you can restrict, for instance, like a hypercube query or a SQL query, parts of the submodels. This is what we are working on in a working group, and here the specification haven't been concluded. And what I found interesting is that one partner here of our Sesame collaboration, Doug, was basically putting in a kind of bullet point list what these queries could or should provide. Yeah, and I think this is something we will really carefully also analyze and try really to provide such a query interface also for very comprehensive submodels, as Erich was pointing out. Basically, a submodel could be also materialize or reflect what a time series database and a large database could consist of. And here we need to create a kind of adequate query interface for sure.
Okay, thank you very much, Michael. I think that was a very good overview, but also coming into some details to answer the question. And yeah, in the end, it reflects it's not an easy and one-directed answer. It's a multi-directed answer, multi-directed thing we have to consider here. And Liliana, in case you have some more questions, then please use our contact information and we would be happy to answer your questions. Okay, thank you very much. I see that there are no other questions in the chat, then we will come back to our agenda. So now if you could share again our agenda. Yeah, our last point is to give you an outlook and conclusion of our session just now. If you come to that slide just now here, you can see we have presented in our session an entire solution from the theory to practice, how to come from the theory, from the request of carbon reporting in the regards of sustainability to a practical implementation and practical solution. And that is what we have provided and presented to you with tools and with tools and solutions from the field of Industry 4.0. And that gives us really the hope and the opportunity that we can solve this topic or also other topics besides of carbon reporting in the area of sustainability with the tools and with the logics and with the information models from the Industry 4.0. Furthermore, we have talked a lot about a demonstrator during our sessions and presentations. You can find in the overview of this demonstrator of the left-hand side of the slide. And we are happy to present this demonstrator in live at the next Hannover Fair in spring 2022 in the end of April. And we would be very happy to meet you there in live on stage and present this demonstrator to you as a tangible demonstrator, so to say, not only in virtual demonstrator. And the last thing I would like to ask you just now in this session here is to get your feedback. We have prepared 3 very short questions. You can find this link here at the slide, and it will also be posted in the chat where you can also post your questions in. And it takes only 3 minutes to put in your feedback, but we really need your feedback, and we would be very interested in to get your feedback at this feedback link here. The feedback link is open over the next days and weeks. We ask you to take the time and put in your feedback. So that is all from our side. Now we are really through that session. And on my last slide, I would like to thank you very much, also on behalf and in the name of all the presenters. They have really done a very good job, put all the things together, first developed that solution for the demonstrators, and put all the things together, tested it out, and prepared that presentation for this forum here. And I liked this very much. I hope you enjoyed that as well very much. And we're looking forward to solve some further topics and upcoming requests from the sustainable area with tools and tool sets from the Industry 4.0. Thank you very much again in the name of the presenters, and have a good day, evening, wherever you are. Stay healthy and connected. Thank you very much.
Thank you a lot.
Thank you.
Thank you.